Good afternoon, everyone. I welcome you all to this module of fog computing. Today, we'll be talking about some applications of the fog computing. As we have discussed previously, the main aim of the fog computing or fogging is to bring the data analysis part so forth so as close as possible to the data source, or the main objective is to bring the analysis part of the data closest to the nodes where this data is being generated. And this gives us various advantages. To start this thing, let's look at a couple of advantages. So some of the advantages that it provides is a greater business agility. When we talk about it provides a greater business agility, means what? It allows us to decide upon right tools and right processes and right systems continuously to develop and deploy the application wherever it is needed. A fog node once programmed to do a particular task, you can deploy it in any like suppose there is an automation industry and you want to collect the amount of data, which is like amount of data of number of what you call as goods which are being provided by a particular belt. So you program that fog node accordingly and deploy it anywhere you require to collect that kind of data. So it provides a this basically does is ki it basically drives machine to function in a way you want it. You can program the node, you can program the fog node in a way you want the process or the automation in whichever machine you have built, you want it to operate and give you the output whatever is desired. Another main advantage of this what you call as uh, uh, fogging is it provides the better security. Better security, there are a lot of applications, lot of data and lot of industries is produced which they actually do not want to transmit it to cloud for further processing it. They want it to process and extract the meaningful information insight only. So in these kind of cases, it provides a much better security than it is available in the cloud. Another very important aspect is that, as you know, the fog node is placed in your premises, so all the security features, protocols and algorithms which are used to secure the fog node are same which are used in internet environment or other IT environments. And as we all know that internet has traveled a long way for security. If we compare the security features which are there for internet are far way advanced than those are available for internet of things. So one good advantage which is provided to us by this is the better security because the features used, or we can say that protocols, or we can say that protocols are same which are used for internet. And as we know that internet of things, the security features are much more developed if we compare them from IoT. So this is actually a kind of one of the very great advantages that fog provide to us, that fog um, provide to us. Now we see the another main security feature for this is deeper insight and the privacy control. As the data is being processed locally, as the data is processed locally. The all the crucial data or the critical data is can be processed is processed locally. So the cloud specialist for cloud analysis team, they can have a better insight of what kind of scenario is going on, and whatever feedback is required they can take it then and there. Moreover, localized feedback can immediately be generated. The responsible people can keep track of the performance of the various machines, devices, nodes, and whatever which are collecting this data, keep track of it and see the performances of the part and particles which are involved in the entire process, and can analyze, and the desired function and the desired control function can be then and there taken. Another one of the important advantage which obviously is the reduced operation cost. First thing which is known for the engineers is that they are supposed to provide the maximum efficiency at the minimum cost. So as we all know that the fog computing saves hell lot of a bandwidth. It saves a hell of a bandwidth. That means it saves a hell lot of money. If fog is not there, suppose we talk about aeroplane only. Aeroplane once flying, it produces 1 TB of data in 30 minutes. If that kind of data, and at every instant thousands of aeroplanes are there flying from one destination to another. If this all data is to be uploaded to the cloud, a lot of bandwidth would be exhausted, and bandwidth is something which is very crucial. We have seen it a number of times, and it has to be it is actually a money. This is optimization of bandwidth itself is called as location management cost. It is basically the cost which is exerted on the service provider, because bandwidth, the frequency range over which this communication takes place is limited. So we have been talking about this in our previous semesters also. Now today we would like to talk about applications of fog computing. We know that fog computing, it actually works best in the cloud control environment and offers a control and a better insight across a wide range of nodes, or what you call as sensors. So the one of the major application of the fog computing is there in smart cities. We know that these days large urban cities, they face n number of challenge in security, sanitization, traffic control, sewer control, then electricity control, and there are this challenge list is endless. The solution to this is basically a single IoT network and developing a control center to that network. The main issues which are there in establishing the smart cities are basically the shortage of, we know that there is a shortage of broadband bandwidth, and another one is due to this bandwidth connectivity also is a main issue. Now the urban cities these days, they have a n number of service providers for the cellular network, like here in Dehradun also Airtel also there, Vodafone, Idea, and couple of year before Uninor, Telenor, pata nahi kya kya, and they have a ample coverage. These networks actually are being operated at the peak capacity and peak bandwidth limits, which in what you call as peak hours, these networks, it become impossible to meet the customer's need. Getting my point? Reason being, you can increase the number of service providers, but the bandwidth which is available for this communication, telephony, or for this wireless communication is fixed. So the solution only is key, you have to deploy these some nodes which should be placed very close to the origination of these data. It should be processed there, stored there, and the desired feedback form be actually generated from there rather than being generated from the cloud. So this is the scenario which is absolutely supported by fog, Also, when we talk about smart cities, security and safety is a major issue. Then health actually is a very important aspect which requires a real time analysis of the data and the feedback to be generated. These all time crucial applications and real time applications, fog has an edge over cloud, because when we talked about fog then cloud, we talked about that fog basically provides you the advantage of reduced latency, real time data analysis, and the what you call as optimized use of the commercial bandwidth. So when we talk about application of the fog, then major application is found in the smart cities. And when we talk about smart cities, we talk about smart buildings. Now these days commercial buildings, they have been equipped in, if we talk about some high tech society, it is equipped with n number of sensors which are there to sense the available parking space and the temperatures, then what you call as what is the status of the then the data produced by the security cameras, and then temperature, humidity, and then data which is produced by the elevators and all and all. So if we keep on transmitting this all data to the cloud, it is not possible. As something goes wrong with the let's say elevator number 3 is malfunctioning, so you need to immediately shut it down. If this data from the sensors of elevator 3 is transmitted to the cloud and then the feedback is generated, meanwhile some casualty might occur. So this way fog computing resolves these kind of issues which are associated with the smart buildings by providing the real time analysis of the what you call as data. Fog computing also permits the local operations for optimized control functions, not only in a what you call as in centralized manner, but if you want, then it can be distributed also, like the data of the sensors which are there to see detect the fire or smoke sensors are placed, can be sent directly, the feedback signal can be sent directly to the guard room or the security room. The data related to the elevators or the technical issues can be sent to the technical team. The data related to the what you call as water storage tanks and drinking water supply tank can be sent to the plumbing department. So this way fog computing provides a very what you call as enormous amount of advantages in case of smart building scenarios. Also it has the very what you call as great advantage in area of visual security. We all know that these days cams are placed for at the public places in society, in parking, to avoid any theft, or parks to keep a watch on kids and all. So if anything unusual is happening, immediate action can be taken up by the concerned department or the concerned team which might be there for combating these kind of situation. Further, we know that these days connected cars or the IoT enabled cars are on the floor. We recently drove one car, Kia Seltos. Some of my friend, he bought it, the top model. So the best like it is of, I don't know, but it is, the top model was of 23-24 lakh rupees. So it was that. It was equipped with everything in that car was equipped with the sensor. As soon as I sat on the what you call as a seat and I tried to adjust it, the friend told me, you push that button, it will sense and auto adjust the seat. The seat was automatically adjusted according to the, like, once it was adjusted, my legs were very well there on the what you call as accelerator and brake, and the height was adjusted so that the screen was perfectly visible. The road was perfectly visible to me by the wind screen. Then whenever you have to take a right turn or a left turn, is when you drive a big car, SUV, you have to take a left turn, it's almost a blind. So as soon as you press indicator to take a right turn in a right hand, in India we have right hand drive vehicles. So as soon as I pressed the right indicator right, entire right side, there was a, I don't know, entire right side means वो the what you call as that, वो नाली जो उसके बगल में होती है रोड के ना, वहाँ से लेकर के कार के ऊपर तक का एरिया, entire thing was covered. My tires were also visible कि how far I am driving from that nali, and it was amazing. And when you take a reverse gear, एवरीथिंग मीन्स एवरीथिंग कि आपके किस टायर से कौन सा पत्थर कितनी दूरी पे है, दीवार आपकी कितनी दूरी पे, एवरीथिंग इन अ 3D व्यू वॉज appearing on the screen normally, on which your normal songs or whatever LCD screen which is placed in center of the car, everything was visible there, and there were n number of examples. So these kind of cars they produce a lot of data. These kind of cars they produce lot of data. Some of them is sent to the manufacturer for the R&D purposes or feedback purposes, and they like it was a car which used to automatically control the what you call as air conditioner and all. Taking an example, today I sent one file to one of the students, and I proposed to adjusting the enabling this car with the sensor so as to ensure the safety of the driver. Suppose a lot of the accidents they take place in Missouri because of speeding. So depending upon the elevation of the road, the elevation of the road can be detected by the sensors, and we can use the angle estimators also. If as soon as your sensor estimates that you are driving on some elevation of 20-25 degrees, the maximum limit should be set to 50 or 60 kilometers per hour, so that even if you press the 100% accelerator, car doesn't move ahead, that rather than a warning signal this is not safe. Moreover, this thing would be advantages and n number of things also. We can place n number of we can place some sensors in a car which actually sense and takes the feedback from the cars which have crossed that road driving ahead of you, and the car which is driving ahead can send the information behind in an open network, which can be collected by the sensors placed in the car, and receives the information that yes, इस point पे there is a pit hole या पेड़ गिरा हुआ या whatever. So these kind of scenarios, the car which is going ahead sense something, and it generates the sensors, they generate the quick information, and that information is replicated on the screens of the cars which are following. So these kind of connected car scenarios is only possible with the fog computing. But the thing is that this data is needed to be analyzed quickly and processed quickly for the meaningful information to be generated. All this thing can be processed using what you call as fog computing. Also for manufacturer point of view or service point of view, other meaningful data like the maintenance, the performance of brake shoe, the performance of engine, the performance of clutch bearing or release bearing, whatever can be directly sent to the manufacturer for the feedback processes. And if something malfunctioning is obtained, it should be sent to the mobile phone of the user, so that he knows whether he is going on a long tour, he should send his car instantly to the service center before what you call as this this long tour. Now another very important use of this is smart grids. Now for effectively running these smart grid systems and utility systems, analysis of this data in a real time manner and controlling of this data is very much essential. Now this data should be processed at a remote site where this your power unit is placed, and this depending upon the extraction of this data, necessary feedback can be done. Now fog computing is actually very much beneficial in this kind of what you call as scenarios. It is actually very important in this kind of scenarios. We'll talk about it slightly later. Let's talk about real time analysis first. Now this data, it may be from large cities or it can be from anywhere, it can be transformed from one place, it can be transformed from the place it is generated to the different places for analysis. If we use the fog computing scenario and the fog computing network is placed near, it can be analyzed then and there. For fog computing, it is used for real time analysis, and for this real time analysis, you are what you call as mature enough to understand how many applications altogether it can be catered by using this real time analysis. Let's take an example of hospitals only. If I take an example of an hospital, suppose let's say that some of the patient is there on what you call as artificial oxygen. Some of the patient is there on let's say artificial oxygen. Some patient is there on artificial oxygen. Now you have placed a sensor, this sensor keep on sensing the oxygen level in the body of the patient, oxygen level in the I don't know, something in the body of patient. As soon as this oxygen level it drops below 90, as soon as this oxygen level drops below 90, the oxygen what you call as the valve of this oxygen cylinder which is supplying the oxygen to the patient shall be automatically open slightly more to allow more oxygen to flow in patient's body. But this is only possible if this data which is generated by the oximeter, which might be data which is generated by the oximeter connected to the patient, this data is analyzed locally. So in this way it can play a very vital role. It can play a very vital role in healthcare application. So when we talk about this electrical gauge, now we were supposed to talk about electrical grids. Now electrical grids are basically smart and dynamic these days. They automatically do the load balancing. Now when we say that it will be responsive while needing less production, and then the electrical supply production automatically, what actually is a smart grid? Let's talk about for 2 minutes. Let's talk about a smart grid is supposed to you can say that it is supposed to sense the consumption and adjust the what's happening, I don't know, and adjust the supply. So this kind of scenario where the electrical consumption is to be sensed and the production is to be adjusted, this kind of scenario is possible only with the use of fog. This kind of scenario is possible only by the use of fog. So smart grid is basically a electrical grid which can sense the consumption and auto adjust the production. This kind of scenario, fog computing things of are very ideal, and some of this data can be generated from single generator sensor or group of sensors. It can be processed then and there to avoid overloading of the cloud, and if suppose in case of heavy generation requirements and electric, your grid is not able to meet that requirement, electricity outage may occur, which is actually undesired when we talk about when we talk about smart cities. अगर स्मार्ट सिटीज़ में ही बत्ती जाने लगी तो फिर you know, this would be very unfortunate case. Now if we talk about we have talked about how this fog computing and etc works. So to compile this thing, we know that fog has advantages of latency, which is reduced. It provides advantage of real time analysis. It provides the advantage of real time analysis, and it provides, last but least, it optimizes the crucial bandwidth. So depending upon these three parameters, there can be n applications of the fog. There can be n applications of the fog computing depending upon this, what you call as latency and real time. Depending upon this latency, optimization of bandwidth, and your real time analysis part. So I guess that shall be enough for this lecture. Thank you.